Welcome to Train Signal. You're watching Managing the vSphere Distributed Switch. So we talked about the distributed switch, the pros, the cons, showed you how to kind of migrate some hosts over after creating and configuring some of the base function of the switch. Now let's talk about, some considerations for deployment. So the distributed switch is controlled and managed by vCenter. So making vCenter resilient becomes extremely important. Back up your database and take good care of it. But a vCenter outage won't affect general VM operation. We'll talk about a few things here in the lab in a minute. But in most cases, vCenter being down just means you can't create new VMs and attach them to the distributed switch. Existing VMs should be able to start up, shut down, and pass traffic without any issue. So make sure it's resilient, but you don't have to go crazy with it. Virtual vCenter, physical vCenter, both fully supported. Just a few things to think about. Really everything will start up fine. One of the issues that we've seen in the past with older versions of the switch, and I know it did this in early versions of 5.0, was if your host came up before your storage was up, it could cause issues with the distributed switch because there's actually some things stored on your data store that kind of seed information. Most of that has been, well, I won't say most, all of that I've seen is fixed. I haven't been able to reproduce that bug. But a lot of people get worried when they're talking about a virtual vCenter with the distributed switch because they think if the vCenter's down, they can't, and it's on the distributed switch, there's this, cyclical redundancy issue, and there's really not. I mean, I run distributed switch often in my lab. I do virtual vCenter. It's not an issue. Just take care of the vCenter. If it comes up and you see something odd, like you had a complete power outage in a data center, make sure storage comes up first, and then bring your hosts up, and then check everything, and you should be just fine. There really should not be an issue. I know people get a little worried about that, but we do those all the time, virtual vCenter on distributed switch, without any issues. A couple of ways to physically separate traffic, and we'll hit this again in more detail in a minute. DMZ or other specialized security limited functionality SSLF environments often need to physically separate traffic. You may have two or more networks. We often separate NAS or iSCSI traffic. You don't want those sharing NICs with other like VM traffic or vMotion. And then confirm standard physical switch port config. Make them all the same. This goes whether it's vSwitches or distributed switches, but it's really important in distributed switches because of the way we do uplink groups. You may have 4 NICs that are uplink groups for your distributed switch. You want to make sure that they trunk exactly the same VLANs, the same configuration, the same edge port mode for spanning tree, all that. You don't want one to be odd that'll cause you a problem later when you go to trunk a new VLAN because it's different. So confirm those are all the same. A couple of design considerations. The designing and deployment of your VDS can be really simple or more involved. As you get more involved, you'll do things like separating traffic. You may do private VLANs. You may do some other special configurations. Or you may just have a pretty, plain Jane kind of a distributed switch configuration. It all just depends on your requirements. Storage should be on its own NICs, DMZ may be on others, and we'll talk about how we suggest you do this in the lab. My suggestion, start with a basic deployment and then start adding in other features such as NIOC or network I/O control. So let's go to the lab. Compare the different. We were going to do a few things here. We've already deployed a switch. I'm going to go through and show you again how to do a host migration, and this time I'm going to show you how to do an entire host in one shot using the wizard. And then I'm going to go back through some of the settings in the main switch to make sure you understand those and some of those that we didn't cover in the last lesson. So we'll look at things like the different port binding methods, implementing NIOC, and just generally taking a look at how to manage the switch. Alright, so back to the lab. A couple of things I want to show you. Let's see. First of all, let's go to inventory networking. I've got a distributed switch built out here that we'll use. And I want to walk through some of the more advanced functions and features, really commands. I want to show you a bit about network I/O control, and also show you a couple of command line tools. So we'll start, let's see, let's go ahead and start doing a couple of things. So first of all, let's again look at the overall switch configuration. So we hit manage. We talked about our uplink names and our number. Again, if you want to do jumbo frames, you'll set that to probably 9,000. If you want to set a discovery protocol, enable or disable. And a great question to be asked would be about this. So just remember, CDP, Cisco Discovery Protocol, is for Cisco devices, obviously. And LLDP is kind of an industry standard version of that, supported by non-Cisco devices. And listen, advertise, or both. Listen means the vSphere host will listen for advertisements from the physical switches. Advertise means the vSphere host will send information to the physical switches, and both means both. You can look at the NICs on your vSphere host, see which physical ports they're plugged on the switch, and then from the switch you can see which vSphere hosts are plugged into which ports. So usually I do both. So not a whole lot to do there. The main thing there is to set your MTU for jumbo frames. Then we have uplinks. Remember that an uplink group is the NICs from a vSphere host that you want to add to this switch. It's kind of like the physical NICs you put on a vSwitch. The couple of things is that often, well, let me rephrase that. You only get one uplink group per distributed switch, and that becomes important in a minute when we talk about how to do traffic segmentation. So we'll get to that in a second. Let's see, what do we need to set here? You set your VLAN trunk range. That's about the only thing you set on an uplink group. So if you want to restrict your VLANs and be a good little network admin and only specify the ones you're going to trunk, you need to specify those here. I'm going to tell you to trunk all VLANs across all the NICs in your uplink group. So if you trunk a VLAN on one, do it across all of them. You could make an argument that if you're going to do traffic separation, say NFS or iSCSI on two NICs and everything else on the other two, you don't need to do that. But for the sake of troubleshooting and configuration, I would recommend it. Don't have to, but I'm going to recommend it. And let's see, if you want to enable NetFlow for this uplink group so you can see how much traffic it's doing, you need to enable it here. And if for some reason you want to block all ports and shut down this uplink group, you can set that to yes. I don't know why you do that, but I'm sure somebody has a use case. If you want to edit any of the override settings, you can do that here. Pretty simple. Again, main things for uplink are which VLANs you're trunking. And then we get down to your port groups. So this is where the magic happens. A few things I definitely want to hit here. First of all, number of ports. So when you add a virtual NIC from a VM or a VM kernel to this port group, it uses a port ID or port number. By default, each port group gets 128. I can make that 256. I can make that 3000. It needs to be set to a reasonable number. The more ports available, the more memory that the DV switch uses. And there's a maximum number per vSphere host and per vCenter, but those maximums have gone up and they're like 20 or 30,000 now. So I doubt you're going to run out, but don't come in here and set this to some wild number. But if you plan to use a full Class C or /24 network here, you may want to set it to 256. The next is how those ports are assigned. There are three ways to do this. Static is the default. It's the default because it's the safest. So what happens is you build a VM, you attach a VNIC to this port group. When you boot that guy up the first time, vCenter hands it a port ID. It says, here you go, you're number 82. Congratulations. That VM's VNIC has number 82 until you destroy the VNIC or the VM. Every time it boots up, it's always 82. That's good. It's good because it doesn't ask vCenter for a new ID every time it boots, so if vCenter's down, you can still boot the VM. It's good because if you vMotion that VM from one host to another, it's always 82, and its statistics for network follow it. The bad thing is that let's say you're in a crazy environment where the limit on the number of ports is 20,000 and you got 30,000 VMs, but only 15,000 are ever powered on at one time. Well, you can't do static assignment, you're going to run out of port IDs. So that's a very, very extreme use case. I've personally never seen that in production, but that's the answer VMware gives me when I ask them why you wouldn't want to do static. So for most cases, you want to do static. Again, that way if vCenter's down, your VMs can boot. You can't create a VM because there's no vCenter to ask for a port ID, but you can boot existing VMs. Next is dynamic. Dynamic means every time a VM boots and its VNIC comes up, it asks vCenter for an ID. When the VM shuts down, it hands the ID back. Good is that if you're in that weird edge case I mentioned a minute ago, it'll still work because you'll have a pool of IDs and you can hand them out and get them back as needed. The bad thing is if vCenter's down, you can't boot VMs. There's nobody to ask for a port ID. And, statistics aren't going to stick around between reboots and things between VMs. So By the way, dynamic is marked as deprecated in 5.1. This is, so it's really a 5.0 thing or a 4.1 thing. I don't recommend you use it, but it's still there. And then you have the compromise, ephemeral. Ephemeral is no binding. Well, how does that work? Well, simply put, when the VM boots up, it gets a port ID for each VNIC from the vSphere host. Each vSphere host has a pool of IDs to hand out. If you vMotion a VM from one to another host, it gets a new port ID on the host where it lands. Good thing is, no dependency on vCenter. No worries if vCenter's down. Bad thing is that if you vMotion a VM around or do anything like that, you don't get to track network statistics as well because your port ID always changes. This will also play havoc with things like port mirroring, just like dynamic will, because if you remember, when we set up port mirroring, it's all based on the virtual switch port ID. If that changes, that's an issue. The only time we use ephemeral is for VDI clients, virtual desktops. The reason being is we really don't want to depend on vCenter, and we really don't care about keeping network statistics for a desktop machine. So we'll often set that for ephemeral. For anything server, we leave it as static. Know these for the exam. In the blueprint, it spells out port binding methods, so definitely know the difference there. And then you go through your policies on the port group. So security policies, here's your 3 settings, the same one that's in a standard vSwitch. Ingress, egress, traffic shaping. So you can enable this and do ingress into the switch or egress out of the switch, traffic shaping. I will give you a tip. First of all, almost nobody uses this. So, that's one thing. Second, these numbers, such as peak bandwidth that it tries to hit, that it allows. This is the most it'll allow at peak, except if you burst up a little higher. But it is per VM. Actually, it's not even per VM. It's per port. So it's per VNIC. So if you have 100 VNICs plugged into this port group, your maximum is 100 times that. So keep that in mind. Everybody thinks it is a aggregate total. It is not. It is a per VNIC total. That's one reason nobody uses this stuff, because it's too complicated to figure all that out. Of course, we talked about this in the last lesson, VLAN tagging type in your VLAN. We have a whole lesson on physical connectivity where we talk about load balancing and these features. And then we get down to failover order. So this is a great time to talk about traffic separation. Now, let's say, for example, that I'm running iSCSI, and I want to dedicate 2 NICs to iSCSI and the other 2 NICs for everything else. How do I do that with a distributed switch and a single uplink group? Well, you got 2 options. One is you create multiple distributed switches. This is my preferred method and the one we use at Vero. It is not VMware's preferred method, though, which is kind of funny. We have a difference of opinion here. But the reason I do multiple distributed switches is I think it's fairly simple to look at. I can log into vCenter and see them. I can name them. I can name one, VDS-iSCSI and one VDS-VM traffic or whatever I want to call it. And then I only assign the NICs for that type of traffic to the uplink group. I think that makes a lot of sense. VMware prefers the single distributed switch method. And in this method, if, for example, I'm on VM network, if I wanted NICs 3 and 4 to only be used for iSCSI, I'd move them down to unused. And you have to go port group by port group and specify which NICs you want to use and which NICs you don't want to use. So I'd go to the iSCSI port group and move NICs 3 and 4 to active and 1 and 2 to unused. And so you have to go through port group by port group and set them. Easy to make a mistake, in my opinion. Must be well documented, because if it's not and you get hit by a bus and I have to come in behind you, I got to figure out why you've got it set this way. So just be careful with that. Choose the method that you want to use, but that's how you separate traffic with a distributed switch. Know these 2 methods. I believe this is called out in the blueprint as well for traffic separation, but know how to use active, standby, and unused. You wouldn't set these to standby because you want to dedicate them to iSCSI. You would move them to unused. So just make sure you understand how to do that. Resource allocation, network resource pool. We'll talk about network I/O control, NIOC, here in a minute. But basically, you can create network resource pools, assign them shares, limit the number of bandwidth, and then you go on a port group by port group basis and assign them to a resource pool. If you want to monitor all the stuff in this port group with a NetFlow, you got to enable it. Because by default, it doesn't send a whole lot to NetFlow because it doesn't want to overrun it with data, so you pick and choose. And then again, you can block all ports if you want to shut everything down. And again, we have our overrides. But you need to do that kind of traffic separation on each individual port group. Remember that. So let's see, before we start doing some host migrations. Next, let's look at NIOC. So click on your main switch and go to Resource Allocation. NIOC is a cool feature that I don't think gets used enough. I actually talked to a customer today about how it doesn't get used enough when they mentioned they didn't use it, but had an obvious use case for it. But the way this works is you can create basically resource pools, and you can also specify on a per traffic type basis the limit on the amount of bandwidth it can use and give it a share value, much like we do shares on CPU and memory. So basically, under times of contention, we get to dictate what slice of the pie a certain type of traffic gets. So here's where you do the configuration. Total number of physical adapters is blank because I haven't moved any hosts to this switch. If I moved 5 hosts with 4 adapters each, it'd be 20. Total network bandwidth capacity. If I moved 21 gig NICs in here, it would be 20 gigabit. If I moved 2010, it'd be 200 gigabit. You'll just see those numbers. And then it tells you if it's enabled or disabled. To enable it, hit Properties and check the box, hit OK. Then we need to do a couple of things. So first of all, there's some traffic types predefined. FT, iSCSI management, NFS, VM, vMotion, and vSphere replication. So these are already built in, and you can go through and say, okay, I only want FT traffic to use, 50 megabit of throughput, which I wouldn't recommend doing for FT. But you can say that's your limit. You can also do it in shares. So it's got some built-in share values, or you can do custom. That's not custom, that's high. You can do custom and give it a number. There's also QoS, Quality of Service Priority Tag. So this does nothing within vSphere. All right. This is for the benefit of your physical network environment. So if you want to tag FT traffic with a certain QoS value, 802.1p as it's called, your network admins can then see that tag and do something with it. Maybe they'll give it high priority, low priority, different queuing method, whatever. You can tag it here and it'll be handled at the physical switch. By default it's none. You can specify the tag. So again, for each traffic type, you can set a share value, a host limit for bandwidth, and notice it's host limit, meaning, if you're running FT on all your hosts and you've got a whole bunch of FT mirrors running, it'll only use 50 megabit per host. That's not aggregate across all your hosts. It is a host limit. And then you can set your QoS tag. So you can do that for each type. The original version of NIOC lumped all VM traffic together. So no matter if it was high priority or low priority, you only got one setting here for VM traffic. But now you can do network resource pools. So we click New, we give it a name, and then you get to specify, again, adapter shares, host limits, and QoS value. And what you do is you assign port groups to this resource pool. So you do manage port groups. Say OK, and now it does it. So you can assign multiples to this pool. It'll, put all of them under the same kind of heading for traffic type. The benefit of this is pretty simple. If I give you a server with two 10 gig NICs, iSCSI on 5.0 and 5.1 of vSphere will use 8 gigabit of that. It'll do 8 vMotions at a gig each maximum. That may cause I/O starvation issues for NFS or iSCSI or even VM traffic. So here you can go in and set shares and say, look, if we start using all of their throughput under contention, here's how I want the percentages and the priorities to break down. Or you can limit the throughput on certain traffic types. So maybe you push down dev traffic, bring up prod traffic, whatever. But it allows you to do that through the vSphere console. It's a very, very good system. I just don't see a lot of people use it. I think they're afraid of breaking things. But especially as we move to the world of 10 gig where we don't have 12 NICs or 8 NICs in a server and we just manually put 2 NICs for this and 2 NICs for that, where everything's in a big old bucket in 10 gig, we need to kind of have some control. So one option is to do it here. Other options are to do it within your physical world, but that gets to be a bit more complex. So I'm a big fan of this tool. All right. So that's NIOC. That's the overall configuration. Last thing I'm going to do is roll a host over and show you that wizard again. Because when I did it before, we kind of walked a host over. I walked over one PNIC, physical NIC, out of each vSwitch and showed you how I walked it over, moved some VMs over, created a temporary VM kernel, did some pinging, and make sure it was all good. Well, now I'm going to try to kind of do the whole thing at once. This is a new vSwitch, so hopefully it's right. Guess we'll find out, won't we? So I want to add a host, Optimus. And let's see, I'll do 2 NICs. Do we want to move our management VM kernel? Yes. To which port group? I've already created one called management. We'll say next. Then it says, do you want to migrate all your VMs? I do. Problem is I got a bunch of VMs on different networks. So by default, I'm going to move everything to the new VM network, and then I'm going to go back and change that. Let's see, untangle. That's the one I'm really worried about. So external needs to be external in DMZ. If I learn how to click again, needs to be DMZ. The other untangle is the same way. So you can pick and choose how you want to do these. The assigned port group lets you do a big multi-select at once. Primarily want to move everything to one network like me, you can do that and then go back and individually filter out what you don't want to do. So let's make sure that should be everything. So we'll hit next. So here's what I'm going to do. I'm going to roll 2 new NICs over, VMNIC2 and VMNIC3 as uplinks. I'm going to roll all these VMs and your management VM kernel over to the port group, and we're going to do all this in one shot. So this is how you do a one-shot move. If I really want to do this one shot, I'd move all 4 NICs because I'm moving everything else. The only reason I'm not moving all 4 is just in case I want to roll it back. So we'll hit finish and we'll see if it works. So it's in process. You'll see it start going through. It'll start, adding everything over, and then it'll start going through the VMs, and you'll see those kick off. And hopefully it'll work. Optimus, configuration, networking, distributed switch. There it goes to the VMs. You can see those tasks kicking off. See the VMs filling in here. See the VM kernel moved over. I'm going to assume that everything is happy. The one you got to worry about is your VM kernel interface, because what happens if I drop my management VM kernel? He drops off the network, right? vCenter stops talking to it, and you end up with a host in limbo. Then you got a host who thinks it's on a distributed switch, but there's a port group problem. For example, if I had set this management port group to the wrong VLAN ID by accident, rolled that interface over, and it was no longer talking, I'd have a problem. Then I had to go to the command line, maybe to the DCUI, and have it rebuild the network, roll it back, and then fix it. Actually, in 5.1, I know the VCAP 5 is on 5.0. 5.1 has a rollback and recovery feature. Basically, anytime you do a change like that, it has a 30-second window. If that host doesn't talk to vCenter within 30 seconds, they roll the change back. So during my VMworld session, I do a demo of this, where I roll it over to an invalid VLAN ID. I set this to like 500. Roll it over, and as I'm talking about it, after 30 seconds, you see vCenter and the host roll that change back in sync, and it rolls this VM kernel back to the standard vSwitch, and the host comes back alive. It's a great feature in 5.1, does not exist in 5.0, but it's a nice 5.1 feature. So it looks like everybody's happy and green. That's good. If we go back to our old vSwitch, there's no longer anything on it. So that's how you do a single host move. Know how to do these migrations for the exam. Know how to walk them over. Know how to move a VM kernel. Know how to move VMs. If they ask you to move a bunch of VMs to a different port group, I'll give you a hint. There's Migrate Virtual Machine Networking. So go to your distributed switch, go to Summary, and here's a wizard. So you can run this wizard manually and say from what to which port group, and it'll do them as you want to. So that's a great tool to use for moving VMs. Let's see. So that's all about that. That's about the uplinks, port group. Show you how to do a migration. If you need to upgrade your vSwitch version, I don't remember if I told you how to do this in the last lesson. This is a 5.0. You can click upgrade. It'll roll you forward to the latest version. It'll confirm that all your hosts are compatible, and then it does a non-disruptive update to the latest distributed switch version. So that's handy as well if they have you do that. Last thing is a couple of CLI commands. There's actually in the blueprint it says use CLI commands to manage the distributed switch. There's not a lot of them. In fact, there's really not CLI commands to manage it. The only one we'll talk about is in a later lesson called net DVS, which is an unsupported command. actually spelled out on the blueprint, but I can't believe they'd test you on an unsupported command, but we talk about that in a later lesson. One thing they do hit is configure SNMP, which I think is hilarious because SNMP support on vSphere is not related to the distributed switch. It's just a management protocol, but it's on here, so I want to show you how to do it. I am on the VMA. This is the vSphere Management Assistant. We talk about this in a later lesson, and the reason I do this is I want to show you two ways to do it. One is using the vi-config command. Actually, let me set an FP target. So I want to issue commands against my host Optimus. VIFP target. I always forget that. You'll probably see me do that 5 more times in this course. I always do FP targets. VIFP target. All right. Prompt changes to show that I'm executing commands against Optimus. So one of them I can do is vi-config SNMP. And what you can do is basically set whatever you want to set. Obvious, right? But the commands are like, if you want to set a community string, it's -C, start and stop the service, traps, port. If you want to return config to factory defaults, it's -R. -S displays the configuration. -T will send out a test. Let's see, -H. Let's see, --config. So what you would normally do is do something like vi cfg snmp, and you want to set a community string of like public. I mean, that's really all you need to do. If you want to set a port, you do -P and the port number. If you want to enable it, it's vi-config snmp-enable. It'll enable the agent. Let's see. If you want to send a test, you can send a test trap to like vi-config snmp, community string -T, and you can basically send whatever you want to send to an address. But that'll send it, 298. I don't really have an SNMP collector, but you can send a test command. Again, it's in the blueprint. I thought it was a very odd location for it to be under the distributed switch. If you want to use it, do it using ESX CLI commands, which you can do from the VMA. One thing about running ESX CLI from the VMA is that it authenticates to the vSphere host, logs in, runs a command, pulls it back, and it adds a bit of delay. So often I'll just log into a host and do it. So for this, let's see, we do system, SNMP, and you can obviously do get to get a config. There's the public community that we saw. You can, let's see, do a test to see if they can be delivered, but I guess I haven't actually set a target yet, so we'll do a set, and you can do set --help, and it'll show you all the commands. So we do -T for target, get that out, and let's say it's 240. I don't actually have one. I gotta set a community string -C public. It's not specified. Interrupt. Oh, maybe it wants it in the other order. CLI system SNMP set 19 community. Forgot the -T. Man, I'm really good at this. There we go. All right. Now, after all that mess, we can do a test. So we can say test, and it'll send one. Now, what I would normally do is go look at the SNMP collector on that host and make sure it received the trap. But again, to set a collector or a target, IP/ your community string for that. So that's SNMP. Again, it's on the blueprint, kind of an odd location. Anything switch related would be under ESX CLI network. So you can do vSwitch, and you can do things like for the DVS, the only thing you can really do is view information. You can't really set anything through ESX CLI. You can through the netDVS command. We talk about that in a later lesson, but again, that's unsupported. So there's not a whole lot you can do here. For the standard, you can do a lot of stuff. You can add, list all my vSwitches. You can remove one. You can set the MTU and CDP status here. So if you want to set -C both, that'll... Oh, I forgot the vSwitch name. -V vSwitch 0. You can there you go. Case sensitive. Yay. You can set CDP on, off, whatever, as well as MTU. All this stuff is stuff you can obviously do via the UI. So it just depends what you want to do. You can set up links. Again, I'm probably going to do this stuff through the VI client because it's faster, but that's up to you. I mean, you know, some people get around really quick. The only time I use command line, even though I'm a big command line junkie on a lot of things, the only time I use it here is if I'm having to rebuild a host networking because I've isolated it for some reason, and I do it via the command line, usually just enough to get it talking to vCenter or the VI client, and then I do the rest through that. So that's it for the lab. Jump back. And that's it for the lesson. So again, things I would know, definitely the different port binding methods, definitely NIOC and how to configure that, create your network resource pools and assign port groups. Definitely know how to do traffic separation and segmentation using active standby and use, since you know you can do multiple distributed switches, but since VMware likes active standby and used, I would do that. Not do different distributed switches. Know how to migrate hosts, know how to migrate VM kernels, know how to migrate VMs, all that good stuff, and know how to configure SNMP. I think that should cover you pretty well on the blueprint. So that's it for this one. Look forward to seeing you on the next lesson.